Hi all, this is Lakshmi, working as assistant professor in the Department of ECE at SNSCT. So today I'm here to discuss about the course electronic circuits, and the topic which I'm going to discuss is about tuned amplifiers. In the previous session we have discussed about what is an amplifier circuit is, and here let us discuss about the tuned amplifiers in this session. So from the name itself, we can understand that this type of amplifiers, they are mainly used to amplify a specific frequency or the desired frequency of signals. Normally, they are used to tune a narrow band of frequencies. So such type of amplifier is known as tuned circuit amplifier. So in an amplifier's load, that is output, a tuned circuit or it is called tank circuit is connected such that it allows or amplifies only the select particular desired frequency, which is a narrow band of frequencies, which means this type of amplifier has good selectivity. High selectivity will be there in case of tuned circuit amplifier. So they amplify a single frequency from a mixture of frequencies in any frequency range. So as discussed, it contains a circuit which is called tank circuit or a tuned circuit. So this is called as a tuned circuit, which is having parallel combination of an inductor and a capacitor. See, so this particular connection is called tuned circuit. This will be inserted in the load of the amplifier circuit. So the values of this L and C will decide the amplification, tuned circuit amplification. So as discussed, so this is the circuit of a common emitter amplifier, where at the load we have inserted a tuned circuit, that is a parallel combination of L and C, and this is a BJT NPN. So where R1 and R2 are given as the voltage divider biasing, and the input signal is given to the base, and we have to improve the stability, we have the emitter resistance which is included here, and with the bypass capacitor CE. So we can see that this is a common emitter amplifier circuit with a tuned circuit L and C. So talking more detail about the tuned circuit here, where LNC plays the major role in deciding the frequency. So when a particular frequency, at particular frequency, if the inductor reactance and the capacitive reactance is equal, the circuit will behave as a resistive circuit. And that particular phenomena, we call it as resonance, and the corresponding frequency is called as resonant frequency. So this is all about the tuned circuit function. And let us now discuss about the classification of tuned amplifier. So there are two major types of tuned amplifiers. One is small signal and the other one is large signal. So small signal amplifier, it is generally to amplify the low signals, and the output of this small signal amplifier power will be low. And normally tuned amplifiers or the small signal amplifiers are operated in class A. So there are three major categories. One is single tuned, double tuned, and stagger tuned. In large signal amplifier, it is mainly used to amplify large RF signal, and here the output power is more, and this can be operated in class B, C, and AB modes. And push-pull configuration is also used to further reduce the harmonic distortion. So the types of this large signal are class B, class C, AB, and push-pull, whereas the small signal are single tuned, double tuned, and stagger tuned, all are operated under class A. So first let us discuss about a single tuned amplifier. So a very simple circuit here. So it is consisting only of a single LNC, that is a tank circuit attached at the load of the output. So as already we have discussed, the value of that capacitance and the inductance will be selected such a way that the resonant frequency will be equal to the frequency at the input signal which is given to be amplified. So initially the high frequency signal which is applied at the input, so that frequency will be equal to the resonant frequency. So at this stage, the circuit offers higher impedance and the signal frequency will help to high output across the tuned circuit. So the high impedance is offered only for tuned frequency, and all other frequencies which get lower impedance are rejected by the tuned circuit, which is inserted at the load of a common emitter amplifier. So you can see that. So this is a circuit of common emitter amplifier. At its load, I have included the tuned circuit LNC. So the values of this inductance and capacitance will decide the frequency, and a high input signal is given at the base here. So the frequency response of the resonant frequency is given by Fr is equal to 1 by 2 pi root LC. So as we have discussed that the tuned amplifier always produces narrow bandwidth. So we can see that the relation between the impedance, the gain and the frequency gives this type of plot, which is indicating the bandwidth is narrow. And the disadvantages of using tuned amplifier. We know that the tuned amplifier is generally they are good, they are having good selectivity. So the high Q factor will be required for tuned circuit. But this high Q factor will give high voltage gain, but at the same time, it will give the bandwidth to be reduced because it is inversely proportional to the quality factor. So the tuned amplifier which is having low bandwidth will not be able to amplify the complete band of signal. So the result will be poor reproduction. So we call this phenomena as potential instability of the tuned amplifier. So the one major disadvantage of tuned amplifier is potential instability due to the high quality factor, which is inversely proportional to the bandwidth. Next is about double tuned amplifier. So as the name indicates, we have two tuned circuits at the load. Such type of circuit is called as double tuned amplifier. So the same circuit we have as such our single tune. The difference here is we have introduced another tuned circuit at the load. So the main applications of tuned amplifier, they are mainly used in the video signal amplification, then for wireless long distance communication, and as radio frequency amplifiers. So these are the major applications of tuned amplifiers. So today's assessment is, so what is the bandwidth of a resonance circuit with a frequency of 28 megahertz and a quality factor of 80? So we know the formula, the relation between the bandwidth and the quality factor, which is inversely proportional. So bandwidth is equal to resonant frequency by quality factor. So by applying the formula, we would obtain the bandwidth as 350 kilohertz. Thank you.